With 6.5, we first need to review some things just about complex numbers or imaginary numbers. First of all, they come from having a negative under a square root. And so they're actually defined, the number, or I is defined to be the square root of negative 1. And if that's the case, if you were to square I, that would mean you were squaring a square root, which would cancel the square root and leave you with just plain old negative 1. So for example, if we had the square root of negative 16 at some point, then we don't usually write all this out, but technically what we can do is split that into the square root of 16 times the square root of negative 1. The square root of 16 is just 4, and now that square root of negative 1, that's the definition, that's what I is. And then so the square root of negative 16 equals 4i. Then when you graph complex numbers, the real part goes on the x-axis. The imaginary part, the part with the I, goes on the y-axis. So if I was going to plot the point 3 plus 2, 1, I would go 3 to the right, and then up 2 for the imaginary part, and that's actually what I would plot. We don't actually draw these lines, I was just doing that for demonstration purposes. So the point 3 plus 2i would be right there. And then this last note is just to warn you, the book often, rather than just refer to 2 plus 3i or 7 minus 2i, they will, I label the point with, and it's often a z. And so when they're going to compare two numbers that you might read about z1 versus z2 in a problem, that's just a way to give them names to make it a little bit quicker to talk about. The first thing we're going to look at is the absolute value, and we'll actually go back to good old-fashioned algebra and numbers. Most people think of the absolute value as just kind of ignoring the sign and just taking the value of the number. But what the absolute value actually means, or what it's referring to, is the distance a number has from 0. And so that's why if you're looking at the absolute value of negative 3, 3 is 1, 2, 3 steps away from 0, or units away from 0. And positive 3 is also 1, 2, 3 steps away from 0. That's why their absolute value is the same for both. And that idea is what we're going to carry over to complex numbers. The absolute value of a complex number, a plus bi, is, and then we use the same absolute value bars, and it's the distance from the origin to the point z in the complex. That should be plain, not plan. Sorry, typo. So, if we are looking at the point a plus bi, a is the distance in the x direction, as we think of it. B is the distance in the imaginary direction, the y direction. And what I'm really after is that distance. That distance is the absolute value, and that it really comes from Pythagorean theorem. I'm really just taking the square root of a squared plus b squared. So we're going to find the absolute value of each of these complex numbers, starting with negative 2 plus 3i. And the first thing we're actually going to do is graph. In the homework, you're going to have to do a little bit of both. So if I'm going to find the absolute value here, and if I'm going to plot it first, I would go start at 0, 0, and then I'm going left 2 for the negative 2, the real part, then up 3 for the imaginary part. So left 1, 2, 3, up 1, 2 would put my point up here in quadrant 2. Then to actually get the absolute value of negative 2 plus 3i, I'm going to do the square root of the real part squared plus the imaginary part squared. And when we're writing the imaginary part, we don't actually include the I. The I helps us plot the point, but when we are actually calculating out the absolute value, we're just taking that number, that 3 that's in front. So negative 2, if you square it, negative 2 times negative 2 gives you positive 4. And then 3 squared is 9. So my absolute value of negative 2 plus 3i ends up just being the square root of 13. And if you were going to describe that distance would be right there. distance from the origin to that point, negative 2 plus 3i. If we try the one on the right here, now I'm graphing and I'm going 1, 2, 3, 4, 5, 6 to the right for the real part, but then down 2 for the imaginary part, which puts me down there. And then if I calculate the absolute value of 6 minus 2i, oops, I don't want a parentheses there. I'm taking the square root of 6 squared plus negative 2 squared. So I end up with the square root of 40. And the absolute value is the square root of 40, which should be this distance. Just to warn you, the one thing you might see, and we worked on this earlier, we're not going to stress it or emphasize it now, but you might see this answer written as 2 times the square root of 10. That comes from splitting this into the square root of 4 times the square root of 10. This is pulling out the largest perfect square and taking the square root of 4 separately to get 2, and then there's nothing more we can pull out from the 10. You don't need to write them that way. We're not emphasizing that at this point, but if you check the back and you don't find the answer you're looking for, that's probably where they got what they do have.